Introduction to ANSYS Fluent, Lecture 5, Solver Settings. The theme of this lecture is that Fluent requires inputs, which we call solver settings, that control the way that it calculates the solution. The purpose of these settings can be understood by introducing the concepts of accuracy, stability, and convergence. And the concept of convergence is especially important in CFD simulation, so extra emphasis will be placed there. In this lecture, you will learn how to choose the solver and discretization schemes, how to initialize the solution, and how to monitor and judge the solution convergence and accuracy. The objective of this material is that you will be able to choose appropriate solver settings for your CFD simulation, and you will know how to monitor and judge the solution convergence. Here, we see a flowchart showing the basic workflow for any CFD simulation. In this lecture, we're going to look at all of the items in the chart in more detail, but the basic overview is that we begin by setting solution parameters, which includes choosing the solver and choosing discretization schemes, and then we initialize the solution. We need the solution to converge, so we define monitors in order to be able to check to monitor convergence while the solution is being calculated. A number of things can be done to ensure the solution remains stable during the calculation, and this includes setting the under-relaxation factors, or Courant number, or pseudo time step. There's also methods by which convergence can be accelerated under certain conditions, and so as the solution proceeds, we check whether or not it's converging, and if it does not converge, then we can modify solution parameters or the grid and continue calculating. Once the solution is converged, there are steps that we can take to ensure that it's an accurate, grid-independent solution, and these can include using grid adaptation. If we feel that there are problems with the converged solution, or that it's not grid-independent, then we can make changes and recalculate the solution and repeat the cycle. Once we are satisfied that the solution is converged and accurate, then we can stop and go on to the post-processing phase. In Fluent, there are two kinds of solvers available, the pressure-based solver and the density-based solver. These are indicated in the diagram to the right. In the next slides, we're going to discuss the individual items in the diagram in much more detail. We'll begin with the pressure-based solvers, for which the training materials and documentation sometimes use the acronym PBS. The pressure-based solvers take their name from the way in which mass conservation is enforced in the numerical solution. The numerical algorithms that are used are called pressure-velocity coupling algorithms, and the way they work is by expressing the continuity equation in terms of a pressure correction. The pressure correction equation is then solved and used to correct the velocity field that's obtained by the solution to the momentum equations in order to ensure that continuity is satisfied. There are two versions of the pressure-based solver, the segregated version and the coupled version. In the segregated version, all of the equations are solved one at a time. First, each of the momentum equations in turn, and then the pressure correction equation. In the coupled version, all of these equations are solved together simultaneously in a coupled manner. For either version, once the momentum and continuity have been solved, the rest of the equations such as energy and any other scalar equations that might be present in the problem are solved in a sequential manner. The density-based solver, which is given the acronym DBS, solves the continuity, momentum, energy, and species equations all together as a coupled equation set. Any other equations, such as turbulence model equations or other scalars, are then solved in a sequential manner. There are two versions of the density-based solver, the coupled implicit and the coupled explicit, and we will say more later about each of these two versions. Choosing the solver is easy. You just select General in the navigation tree and then select either pressure-based or density-based.